I hope everyone had a really nice long weekend. Cal, did you have a great long weekend?
No.
No, he didn't. He's not feeling very well. Georgie, did you have a great long weekend? Yay! We're going to get into lesson 10. It's going to be really straightforward and a wonderfully simple way to start the week. In lesson 10, we are adding fractions with unlike denominators. Yeah. Georgie's saying that we're just going to use a traditional algorithm to find common denominators. Yeah, and Cal's saying, don't be afraid, you guys. The sums are going to be greater than 1, but you could totally handle it because I believe in you. What else? Oh, cough. What else do you have to say, Cal? Can you say jingle bells? Cal's not doing any of these tricks. He's not really feeling that well. But Georgie, watch your show. Yeah. Georgie's really excited for lesson 10, so I don't want him to wait any longer. Here goes nothing. Let's do this. Yay!
Okay, let's find the other one.
Okay, kiddos, here we are, lesson 10. I think my pen is fully recovered from its incident on Friday. So we're looking at 4 2/3 plus 1 2/5. What we're going to do is rewrite the problem and leave some room for ourselves because, as you guys know, Eureka, the powers that be at Eureka, we love them, but they don't leave us a ton of room for working. So there are, as you guys know, multiple ways to find common denominators. The way that we're going to use right here is just doing some good old-fashioned skip counting because Chloe loves skip counting, and gosh darn it, so do I. So we're going to skip count by each of the denominators, and what we're looking for is a common number between the two of them. So, Tracy, can you lead us in the skip counting? Thank you. So we have 3, 6, 9, 12, 15, 18, 21. So we'll pause there. And then let's skip count by 5. Alex, can you help us with that? Thanks, buddy. 5, 10, 15, 20. I hear someone screaming. Kyle, yes, why are you screaming? That's right, Kyle. Kyle notices that 15 is a common number on both of our lines. So we're going to use 15 as our common denominator, meaning we're going to rewrite both of those fractions, 2/3 and 2/5, as an equivalent fraction, as a fraction that represents the same amount, but this time that fraction is going to have a denominator of 15. So this is what we have to think about. We multiply 3 by what number to make it a 15? Gabby, thank you. We multiply 3 by 5 to make it a 15. And you guys know about the insanely jealous numerator. Oh my gosh, what did I just do? Sorry, Claire. Claire was just about to tell us the story of the insanely jealous numerators that insist on being treated exactly the same. So if 3 is being multiplied by 5, you better bet your buttons that 2 needs to be multiplied by 5 as well. So 2 times 5, well, 3 times 5 is 15 indeed. 2 times 5 is 10. So 10 15ths is equivalent to 2/3. Because as we talked about in lesson 9, all we're ultimately doing here, you guys, is multiplying 2/3 by another version of 1. 5/5 can be rewritten as a whole number 1. So we're just transforming 2/3 into an equivalent fraction. It still represents the same amount, but this is just a different version of 2/3. This version has a denominator of 15. And you know what? I did not leave myself the room that I wanted to over here. That's very Eureka-like of me. Okay, so now let's look down here. We're going to multiply 5 by what number to make it a 15? We're going to multiply 5 by what number, Fiona, to make it a 15? Thank you, my lady. We're going to multiply 5 by 3 to make it a 15. And now, Charlotte, the excellent storyteller, Charlotte can tell you later about the absolutely unbelievable saga of the insanely jealous numerator 2 that insists on being multiplied by the same number as the denominator. So if we multiply 5 by 3, you can ask Charlotte for more information, but Charlotte insists that 2 is insanely jealous, and 2, the numerator, must be multiplied by 3 as well. So 2 times 3, thank you, Charlotte, is 6. So we've rewritten our expression. We've transferred both of our fractions into equivalent fractions with denominators of 15. And I've just brought down the whole numbers. There's no reason to play with the whole numbers at all. Now we can just add. 4 plus 1, thank you, Jonathan, is 5. And then 10 plus 6 is 16, and our denominator is 15. What we're really going to push ourselves to do in lesson 10 is to simplify. George is excited about that. So, yeah, I know, buddy. So we're going to rewrite 5 and 16/15. We're going to decompose 16/15 into 15/15 plus 1/15. Oh, Georgie's upset about that. You know what, buddy? They are totally ready to decompose and simplify numbers. So we decompose 16/15 into 15/15 plus 1/15. We're going to simplify this one more time and show. Georgie's sitting. Oh yeah, Dad. Georgie's sitting in my lap. He didn't want to miss out on the action. We're going to simplify this once more because we know 15/15 is just a fancy way of saying number 1. So we're going to rename 15/15 as 1. Oh, Georgie, you are not helping. Georgie, I don't know how long this is gonna last. Yeah, could you grab him? Abba. Georgie loves math. I know. Sorry, guys.
1, 2, 3.
Georgie wants to use the pen. Okay, so we simplified. Thank you, honey. We simplified 15/15. It's gonna be able to get that into 1. 5 plus 5 plus 1. Sorry, this is getting a little sloppy. Plus 1/15. We rename 15/15 as 1. 5 doesn't change, and then we had 1/15 left over after we decompose 16/15 into 15/15 plus 1/15. Our final answer here is 6 and 1/15. Wow, that was really great job, you guys. Let's do one more. Okay, kiddos, one more simple one, and then we'll do a word problem, and I'm done. 15 and 1/5 plus 3 and 5/8. Let's rewrite the problem so that we have some room to work out our common denominators. So we have 15 and 1/5 plus 3 and 5/8. Okay, so 5 and 8, very clearly not common denominators. And I'm analyzing them, I'm thinking, and it isn't immediately obvious what number they have in common as far as multiples go. So this time around, instead of skip counting, I'm just going to multiply the denominators together. Georgie agrees with Mama. Thank you for that support, Georgie. I'm just going to multiply 5 times 8 to get 40, and we're going to use 40 as our common denominator. And we're going to bring down our whole numbers. Do not forget to bring down those whole numbers. Oftentimes they get left behind, and understandably their feelings are really hurt, and if you do not bring down those whole numbers, it's clearly really going to affect your final sum. So now we have to think about, what did you multiply 5 by to get 40? Well, we just multiplied it up here. Hopefully you remember that back that far. We multiplied 5 by 8 to get 40. And if you multiply the denominator by 8, you must multiply the numerator by 8. What is 1 times 8? It is 8. Down here, we are converting 5/8 to a fraction with the denominator of 40. So you guys know that we multiplied 8 by 5 to get 40. And you also know, I see Ethan shaking his head, that you have to multiply the numerator by 5 because we multiplied the denominator by 5. And 5 times 5, thank you, Evan, is 25. So now we can just go ahead and do our very straightforward addition. 15 plus 3 is 18. Thank you, Kylie. 5 plus 25 is, our denominator is going to stay the same. Did I say 5 plus 25? I meant to say 8 plus 25 is 33. So 18 and 33/40 is our final answer. Look at just a very simple word problem. Erin jogged 2 1/4 miles on Monday. Wednesday, she jogged 3 1/3 miles. And on Friday, she jogged 2 2/3 miles. How far did Erin jog altogether? Let's zip all of the information that we're given into a diagram, tape diagram that is. And let's pretend that this is a perfect rectangle. This rectangle is not proportional, nor is it really a rectangle because we have this mysterious hump here in the center. So we have 2 1/4 on Monday. We have 3 1/3 on Wednesday. We have 2 2/3 on Friday. And we want to know, what did she run during that week? So the expression that we're looking at is 2 1/4 plus 3 1/3 plus 2 2/3. Good news is we have 2 common denominators already. 3 and 3 are the same number. And now we need to figure out a common denominator between 3 and 4. I think that you guys are probably already doing this in your head. Multiplying 4 by 3 together to get 12. And indeed, we're going to use 12 as our common denominator amongst 4 and 3. So what we're going to do is we're going to rewrite this expression as mixed numbers with containing denominators of 12. So we're going to bring down our whole numbers as we rewrite our expression. So we're going to bring down our whole numbers. We're not going to do anything to our whole numbers, but we're going to start transferring our fractions into denominators. We're going to start, translating our fractions to have denominators of 12. So up here, we have to think about, we multiplied 4 by 3 to get 12. And you guys know that we also have to multiply the numerator by 3 to get 12. And 1 times 3, very simply, thank you, Ollie, is 3. Here we multiplied 3 by 4 to get 12. So if we multiply 3 by 4, we have to multiply 1 by 4. And 1 by 4, thank you very much, Eric, is 4. Here, sorry, I'm bravely doing this video right here. The baby's playing. I think everyone is just about done. Good thing I'm almost done with my video. Speaking of which, Mr. Calamares, what is the secret word for today?
Vikings.
Oh, you might have some people getting a little upset with you. Okay, we'll go ahead and let Mr. Calamares set the secret word as
Vikings.
Okay, so you guys are responsible for bringing that to me tomorrow morning on Tuesday. Let's finish up with this problem here. We multiplied 3. I already did this. We multiplied 3 by 4 to get 12. So that means we also have to multiply 2 by 4. What is 2 by 4? Thank Thank you. It is 8. Thank you, Kate. Okay, so now we have 3 mixed numbers, each with a common denominator of 12. And now we just go ahead and add them up together. Let's add our whole numbers first. 2 plus 3 is 5. 5 plus 2 is 7. And now let's add our fractions up. 3 plus 4 is 7. 7 plus 8 is 15. So we have 7 and 15 twelfths. Let's go ahead and decompose 15 twelfths into 12 twelfths plus 3 twelfths. Because 12 plus 3 is equal to 15. We just decomposed 15 twelfths into 12 twelfths and 3 twelfths. So now let's just simplify this one more time. 12 twelfths is a fancy, oh, I'm coming, Georgie, is a fancy way to just say whole number 1. Whole number 1 plus 7 is 8. 7 plus 1 is 8. So we have 7 plus 1, 8, and 3 twelfths. Okay, Georgie's feeling sad because the video is over. We'll make another one again, Georgie. Have a great night, you guys. Look forward to seeing you tomorrow and having an awesome week with you in Math Plan.